Have you ever stopped to think about how we're teaching computers to, well, to read our minds? Or maybe not our minds, but at least our emotions, just from the words we type? That's the fascinating quest we are diving into right now.
Okay, so let's just jump right in with a little puzzle. Look at this sentence. Is this review positive or is it negative? Now, you and I can see it's kind of both, right? It's mixed. But for a computer, this is a real head-scratcher. You've got a strong positive and a strong negative, all tangled up in one thought. And this is the exact problem we're going to unpack.
So, to figure out how a machine solves a puzzle like that, we first need to get on the same page about what we're even talking about. Let's lay down the groundwork.
At its heart is something called sentiment analysis. You might also hear it called opinion mining, and it's exactly what it sounds like. It's all about teaching computers to find and categorize the opinions, the feelings that are hidden inside our words. It's about getting a machine to finally understand the vibe behind the text.
Now, this whole analysis thing isn't a one-size-fits-all deal. It can happen on different zoom levels. You can look at the overall mood of a whole article. You can zoom way in on just one sentence, or you can get super specific. And that brings us right back to our little puzzle. Using what's called aspect-level analysis, a machine can actually learn to see that the camera was awesome, but the battery life, not so much. All in the same review.
So how did we even start teaching machines to do this? Well, the very first try was probably the most obvious one you could think of. We gave it a dictionary.
This is called the lexicon, or dictionary-based approach. It's basically like giving a computer a dictionary of feelings. The machine chops up a sentence into individual words, looks each one up to see if it's positive or negative, like excellent gets a +1, disappointing gets a -1. And then it just adds up the scores. The final number tells you the overall sentiment. Simple, right?
And yeah, this method is simple and it's fast, but wow, the limitations are huge. It has absolutely zero understanding of context. It completely whiffs on sarcasm. Just imagine a computer analyzing, oh, great, another delay. It would see the word great and think, hey, this is positive. This is the brick wall that the dictionary approach smacks right into, and it's exactly why we needed a much, much smarter solution.
And this leads us to a massive shift in thinking. Instead of giving computers a dictionary and a list of rigid rules, the question became, what if we could just get them to learn what's positive and negative all by themselves?
And that is the core idea behind machine learning. We just feed an algorithm thousands or millions of examples. We show it tons of movie reviews that a human has already labeled positive or negative, and we just let it go. It starts to figure out the patterns for itself. It learns which words and even which combinations of words tend to pop up in good reviews versus bad ones.
This created a whole new toolkit of classic algorithms. Things like naive Bayes and support vector machines became the new heavy hitters. Think of them as really sophisticated statistical engines. They were way more accurate and flexible than the old dictionary method because they learned from real-world language. But they still had one major fundamental blind spot.
And here's the crucial thing. These models often just threw all the words into a virtual bag. They knew which words were in a sentence, but they had no clue about the order of those words or how they related to each other. So to these models, the dog bit the man and the man bit the dog look almost the same. But we know they are not even close. To really get language, a machine had to finally understand context.
And this is where the story gets really, really cool. The deep learning leap. This was the moment we finally started building models that could read a sentence more like a human does by understanding that a word's meaning changes completely depending on the words that are sitting right next to it.
And the pace of progress here has been just breathtaking. Around 2014, models like LSTM started to process words in order, which was a huge step. But the real revolution came around 2018 with a model called BERT, and that was quickly followed by huge foundational models like GPT. The game had totally changed.
So, what made BERT so special? Well, the B in its name gives us a huge clue: bidirectional. Unlike older models that read a sentence just from left to right, like you're reading a book, BERT reads the whole sentence at once, looking both forwards and backwards to understand the full context of every single word. It can figure out what a word means by looking at everything around it. This was the key that unlocked a much, much deeper, more nuanced understanding of our language.
Okay, so now we have this incredibly powerful tech. Let's talk about where it's being used all around us today. And, just as importantly, where it still gets tripped up. Because, human language is messy.
You're bumping into sentiment analysis all the time, probably without even realizing it. Companies use it to track their brand's reputation on social media, like in real time. E-commerce sites use it to magically summarize thousands of product reviews.
And customer service departments use it to automatically flag an angry customer's message and send it straight to a human. It's everywhere.
But for all its power, it's not perfect, not by a long shot. Because as humans, well, we don't always say what we actually mean.
Take sarcasm. When you say, "I just love being stuck in traffic," we instantly get that you mean the exact opposite. But an AI, even a really advanced one, can look at the word love and get seriously confused, struggling to see that the positive language is actually communicating something deeply negative.
And it's the same thing with irony. It's all about that little gap between the literal meaning and the intended meaning. And that's a gap that AI is still learning how to see across.
And finally, context is everything. Think about the word sick. In the world of gaming, that move was sick is about the highest praise you can give. But if you're talking to your doctor and you say, "I feel sick," it's obviously negative. It's the exact same word with the opposite sentiment, and it all depends on the world it's being used in. Which brings us right to the edge of today and into our final section. Now that machines are getting so good at this, where is this whole quest heading next? Well, the future is incredibly exciting. We're moving towards what's called multimodal analysis, where an AI won't just analyze your words, but also your tone of voice, and maybe even your facial expressions to get the full picture. We're also pushing hard for explainable AI, so the machine can actually tell us why it thinks a review is negative. The goal is a richer, more transparent, and more accessible understanding of human emotion.
And that's what we'll leave you with. We started this whole journey by asking a computer if a simple review was positive or negative. But as these systems get powerful enough to read the room on a global scale, the real question isn't what the AI can answer, but what are the right questions we should be asking it in the first place? Thanks for joining this explainer.